Assalamu alaikum, brothers and sisters. Welcome to the journey of Quest, where we quench your thirst of knowledge. Ever wonder how engineers predict the behavior of materials under stress? Mohr circles might be the answer. These clever constructs are more than just circles. They're a powerful tool that helps engineers understand what's happening beneath the surface of materials when forces are applied. It's all about stress states, the internal forces that materials experience when they're pushed, pulled, twisted, or otherwise stressed. Imagine a piece of rock deep underground, or a metal beam in a skyscraper. Different forces are at work, causing different types of stress. Compressive stress, tensile stress, and shear stress, to name a few. Mohr circles help us visualize these stresses, making them easier to understand and predict. This is fundamental knowledge for engineers, architects, geologists, and anyone dealing with materials under stress. It's the world of stress states and Mohr circles. So, ready to dive deeper into this world? Hold on, as we're about to get technical. First off, what exactly is a stress state? Let's unpack that. Stress states in the realm of engineering refer to the different ways a material or an object can experience stress. This stress is basically the internal resistance of a material to the external forces applied on it. Imagine you're trying to squeeze a marshmallow. It resists your squeeze to some extent, right? That's a simple way to think about stress. Now, there are three main types of stress states that we need to understand: axial, shear, and torsional stress. Let's take a closer look at each. Axial stress, also known as normal stress, is the type of stress that occurs when a force is applied perpendicular to the surface of an object. Think about pushing a door open. The force you apply is directly perpendicular to the surface of the door, causing axial stress. Next up, we have shear stress. This type of stress occurs when a force is applied parallel to the surface of an object. Imagine sliding a heavy box across the floor. The force you're applying is parallel to the floor, and the box experiences shear stress as a result. Finally, we have torsional stress. This is the stress state that occurs when a force is applied in such a way that it causes an object to twist. Think about wringing out a wet towel. The forces you apply with your hands cause the towel to twist, which is a perfect example of torsional stress. These stress states are crucial in understanding how materials and structures behave under different conditions. They help us design safer, more efficient structures and machinery by allowing us to predict how they'll react to various forces. So, now that we have a handle on stress states, let's move on to Mohr circles. Mohr circles, despite sounding quite mathematical, are surprisingly intuitive once you get the hang of it. Now, let's delve into the concept of Mohr circles. Named after German civil engineer Otto Mohr, these circles are a powerful tool for visualizing and understanding the different states of stress that a material or structure can experience. Imagine you're handed a map, but instead of cities and roads, it's filled with states of stress. This is essentially what a Mohr circle is, a graphical representation of stress states. Each point on the circle corresponds to a different stress state, and by moving around the circle, we can explore how these stresses change under different conditions. So what's with the circle? Why not a square or a triangle? Well, the shape of the circle provides us with some valuable insights. The center of the circle represents the average stress, a kind of middle ground between the maximum and minimum stresses that the material can withstand. This average stress is significant because materials often fail when this average stress exceeds their strength. Now let's talk about the radius of the circle. The radius is not just a random measure, it's directly related to the range of stresses the material can withstand. A larger radius means a broader range of stress states, indicating that the material can handle a wider variety of loads. In essence, a Mohr circle is like a stress compass. It helps us navigate the complex landscape of stress states, providing us with a clear and intuitive way to understand how different loads can affect a material or structure. So, to sum up, Mohr circles are graphical representations of stress states. The center of the circle represents the average stress, and the radius tells us about the range of stress states that the material can withstand. With this basic understanding of Mohr circles, let's explore how to construct one. Constructing a Mohr circle may seem challenging, but it's actually a systematic process. Let's walk through it together. Step 1. Identify your stress state. This is the starting point of our circle construction. The stress state gives us two important values, the normal stress and the shear stress. These are the two main components we're going to be working with. Step 2, plotting the stress state. Here we will plot the normal stress on the x-axis and the shear stress on the y-axis. This point represents your initial stress state. Step 3, drawing the Mohr circle. Now, imagine a line from the origin of the graph to the point representing your stress state. The midpoint of this line becomes the center of your Mohr circle. With this center point identified, we draw a circle that passes through our stress state point. This is the foundational structure of the Mohr circle. Step 4, identifying principal stresses. These are the maximum and minimum normal stresses, occurring when there is no shear stress. They lie on the x-axis and are represented by the points where our circle intersects with it. Step 5, determining the maximum shear stress. This is the highest point on the circle, located directly above the center point. It represents the maximum shear stress that the material can experience without failing. Step 6, illustrating planes of stress. These are lines drawn from the center of the circle to any point on the circle. Each line represents a different plane of stress within the material. And there you have it, a complete Mohr circle representing a specific stress state. But how do we interpret it? Interpreting Mohr circles is where the real magic happens. It's like reading an ancient map, where every point, line, and curve has a unique story to tell about the state of stress within a material. To start with, the 2 points where the circle intersects the horizontal axis represent the principal stresses. These are the maximum and minimum normal stresses that act on an element. The principal stresses are significant because they reveal the maximum normal stress a material is subjected to. This information is crucial because it helps engineers anticipate potential failure points and design safer structures. Now, if we look at the center of the Mohr circle, it corresponds to the average of the principal stresses. This average stress is a key factor when considering deformations because it gives us insight into how the material will behave under the applied stresses. Moving on to the topic of shear stress, the maximum shear stress is represented by the radius of the Mohr circle. This tells us the maximum shear stress that the material can withstand before it begins to deform or fail. It's an essential parameter in design and analysis, particularly when dealing with materials prone to shear failure. But the Mohr circle isn't just about stresses. It also provides valuable information about the orientation of these stresses. The angle at which the principal and maximum shear stresses occur can be determined from the Mohr circle. This helps engineers understand the directional characteristics of the stress state, which can be vital for certain applications. In the grand scheme of things, Mohr circles give us a comprehensive picture of stress states, providing both magnitude and direction. This makes them an invaluable tool in the field of engineering, helping professionals make informed decisions about material selection, design strategies, and safety considerations. And with that, you're now equipped to understand, construct, and interpret Mohr circles. So let's quickly recap what we've learned today. We started our journey by understanding the different states of stress, which are essentially the internal forces experienced by materials. We learned that these stress states can be visualized and analyzed through a powerful tool called Mohr circles. We then dove into the Mohr circles, understanding their significance and how they are constructed. We discovered that these circles are not just simple geometrical figures, rather, they are a graphical representation of the state of stress at a point in a material. Next, we mastered how to construct a Mohr circle, a process that involves identifying the principal stresses, calculating the radius, and plotting the circle. Finally, we discussed how to interpret Mohr circles to derive meaningful insights about the stress state. With this knowledge, you're one step closer to understanding the fascinating world of materials under stress. Until next time, keep learning, keep exploring. Thanks for watching us share our videos, subscribe our YouTube channel, and press the bell icon, and stay curious for new uploads.